Okay, welcome to another building a model in RC Crew Chief. What I've got sitting here on my desk is an associated B5M. This is freshly built, so it shouldn't have any bent, warped, twisted, or impaled parts on it. It hasn't even been on the track yet. So what I'm going to do here, the main thing I'm going to focus on is the measuring the front suspension. Because of this car has an awful lot of kick up on the front, you have to do your measurements a little different to get your pivot points. So I'm going to start dismantling the front suspension. I'm not going to bore you with that, so I'm going to turn off and I'll be back again in a couple minutes. Okay, I'm back, and you can see I've been a little busy. I've dismantled the entire front suspension. I've completed pretty much all the measurements on the front suspension. The only two that I haven't done are, set this aside for a sec. So I've done all my Y2s, or so I've done my X2, which is the center to center for the upper camber link. I've done the X1 and the lengths of the arms, camber links, and so on. The dimensions that we're going to look at doing here that are the trickiest ones of all is the Y1 dimension and the Y2 dimension. You see I've already done a calculation here, but I'm going to show you how I came up with that. Okay, so you'll see I've clamped on a bar here, and the reason for that is we always have to be measuring to a common place, particularly for suspension pickup points. So our baseline is the underside of the chassis, and because of our kick up that we've got here on this this piece, I need to extend out my chassis. So essentially I just gently clamped a bar on there that allows me to extend out, and I can take some measurements relative to that and just subtract the thickness of the bar out of the measurement. So what we're looking for is the middle of this hinge pin. Okay, we're looking for the dimension from there to the chassis. So we can do that a couple ways. First way I'm going to do it is to just take measurements and do some averages and show you a result that way. And another way I'm going to do is to take fewer measurements, more accurate measurements, and use a little math to do a more accurate determination of where that point is. So first let's do the just measurement method. So I'm going to measure on the upper side of this where the hinge pin touches the mounting block, and that is going to be, get this to settle, 24.3, let's call that. And then we're going to measure on the back side of this, and then we're just going to take the average of those two numbers to give us what the height would be at the middle. So I'm going to measure on the back side here, so we do the same thing, and we get about 15 point, let's call it 15.75. It's kind of fluctuating around, and it's very difficult to get in tight into that space. So to determine what this point is, then it's quite simply just the distance at the top end, which was 24.3, plus the distance at the bottom end, which we just measured, was 15.75. Divide that by 2, that gives us that average number. Then we subtract off the thickness of our plate, and we subtract out 1/2 of the diameter of the hinge pin, and that gives us one number. I'll show you results in a second. But so the other way we can do this, which is more accurate but involves some math. So essentially what we do, I don't even need this anymore. So method 1 here, I've done that calculation, it's 9.41 millimeters. Method 2, what we do is we just measure the distance to the top edge there, which we already did was 24.3. Then we measure the length of that block, which is 18.6 millimeters. And those are the only two measurements we need to make. So what we want is the center point of the block here. So that's going to be 1/2 of 18.6 or 9.3 millimeters. So what we do is we do a little bit of math here to determine what this Y mid dimension is, how far down that comes. We know that the kickup on this car is 25 degrees. So Y mid is just going to be 9.3, which is the difference or distance to the midpoint, times the sine of 25 degrees, which gives us 3.93 millimeters. So now our Y1 is 24.3 minus our Y mid, which is 3.93, minus the same two numbers we did at the beginning or for the method 1, which gives us 9.75. So there's 0.3 millimeters difference, which may not sound like a lot, probably isn't really a lot when you consider it's not really easy to do 100% accurate measurements, but given a choice, this is the method that I would use, and this is the method I will use. So that just shows you you can do you can get at things a few different ways. Sometimes you have to be creative, and if you paid attention in math class and wondered where you would ever use some of that weird stuff they taught you, well, here's an application for it. Okay, I'm back again because I almost forgot to show you guys how to determine the Y2 dimension. So our Y2 dimension, what we want is we want the distance from the angle that the suspension arm moves in, which is the angle of the hinge pin, to the center of this pivot ball. So on this car, it's pretty easy to measure that. We just have to measure from the top of the ball stud, down to the lower hinge pin, which is, am I getting on that properly? Which is 29. That's what it's been every other time I measured it, so I just want to make sure I got the same number again. So what we need now, so we've got our Y1 dimension, which we just calculated, plus our 29, and then we got to subtract off half of the hinge pin diameter, and then we also have to subtract off the distance from the top of the ball stud to the center of the pivot. Now that dimension, you could just say it is half of the diameter of the ball stud, but that would be slightly wrong because there's a flat on the top of the ball stud, which means it's not a perfect sphere. So we can correct for that. It takes a little calculation. Here's the calculation. I'm going to build this into the program actually as one of the calculators in the program. So you need to take the three measurements of diameter of the ball, the width of the flat section on the top of the ball stud, and the overall length from the bottom of the shoulder to the top of the ball stud. So knowing those dimensions, you can calculate this D value, which is the distance from the top of the flat down to the center of the pivot point, which is, in this case, is the number that we actually want for our calculation, because we got to back that out. So in this case, it comes out to be 2.09 millimeters. If you were measuring from, if you wanted the distance from the shoulder to the center of the ball stud, then that would be, you know, this overall length minus that 2.09, which would be 5.45 millimeters. So that's what we've done here. After you see all my scribblings. So we got Y1 plus 29 minus 2.9 over 2 minus the 2.09, which gives us 35.21 millimeters. So that is the Y2 dimension to enter. Okay, that's it. Now I'm